Hello friends, today I want to talk to you about Arduino. What is Arduino, how it was created, who made Arduino, for what purposes it can be used. I will try to give as much detailed information about them as possible. Let's start right away so as not to take too much of your time. First of all, I haven't uploaded a video for a long time. I apologize for that. This is the first video of the Arduino tutorial series. I hope my videos will be useful for you. Arduino is a physical programming platform consisting of an I/O board and a development environment, including an implementation of the processing/wiring language. Arduino can be used to develop interactive objects on its own or connected to software running on a PC. Ready-made boards can be purchased, or information on hardware design is available for those who want to build their own boards. The founder who invented Arduino was founded by 4 partners. These partners are Massimo Banzi, David Cordiales, Tom Igo, and David Mellis. The development of Arduino started at the Ivrea Institute for Interaction Design in Italy. Arduino serves as the brain of the technological devices, handmade robot, airplane, and drone designs that are frequently designed today. Okay, I think this technical information is enough. First of all, you can see from the pictures that there are many types and models of Arduino. Now let's examine the Arduino R3 model I have. This model is one of the most used, and it is a clone Arduino. In fact, there is almost no difference from the original Arduino, so you can use it in the same way. Now let's take a look at the components on it. I must say that using Arduino requires a basic knowledge of electronics and software. If you are already interested, you can learn on your own. I will try to explain both electronics and software as detailed and understandable as possible. First of all, it is this small CPU that controls the circuit. I will not go into too much technical detail and confuse you. You just need to know that it's the brain of the circuit. The other circuit element here provides communication between the computer and the system's processor. This section contains data and energy input. So through this port we plug the circuit into the computer, and the system receives both data and energy from the computer. Computer supplies 5-volt power to the system. For this purpose, manufacturers usually include such cables in Arduino kits, but you can also buy them individually. One end of the cable is a normal USB socket, which means that we can feed the Arduino with any source that has a USB port and provides the required 5 volts. The other socket is the input where we can only energize the Arduino. You cannot upload data from here. From this input, we can energize the system between 7 and 12 volts. It is recommended not to exceed this voltage value. To use it, you use connections like the one below, which is also available in Arduino kits. You can connect a 9-volt battery to this connector and power the Arduino with energy or any power supply. Now I will use a 9-volt battery. This is how we install it, and if you have installed the necessary codes, the system is ready to run. There is also a reset button here. If you want to restart the system, just press the button, and you don't need to disconnect the power. Now let's talk about Arduino's connection pins. Without these pins, you cannot use any sensor, module, driver, or motor needed with Arduino. There are pins arranged in 2 rows like this, and it is very easy to use. The purpose of each pin is written on or next to it. The cables are produced in this way so that we can make easy connections to these pins. You can easily remove and install them. Usually this system is prototype and used in experimental projects. But if you have a permanent or long-term project, you need to use more compact connectors. This is how you connect the cables to the pins you specify in the software. Yes, you should definitely inform the system with specific codes what you connect the pins you use and what you want Arduino to do. In the next second video, I will talk about the coding interface and the software language. We are already going to do a lot of projects together. Now let's see what the pins we will use frequently are for. When we hold the board in this way, we see that the first pin in the power section is idle. The second pin is the 5-volt reference pin. The third pin is the reset pin and does the same job as the reset button. So when the required signal is applied to this pin, the process starts again, just like when you press the reset button. The next fourth pin is the 3.3-volt output pin. Here and on the fifth pin just below it, there is always a voltage output if you have powered the system from any socket. Fifth pin, 5-volt output pin. We can get energy from it. The next two pins are G and D, the negative output line. With 3 and 5 volts, we use these pins as negative. The last pin in the power section is the voltage input pin to power the Arduino. Here you can energize the system. Just below it is the analog in section. The pins in this section allow us to use analog sensors and modules. We will talk about sensor types in the following videos. We provide data to the system from various sensors and modules that we connect to these pins and tell Arduino what to do with this data. With the appropriate coding and hardware, Arduino happily does what we want. SCL and SDA pins not shown in the picture are at the top. SCL is the analog input clock line and SDA is the analog input data line. Just below it is the analog reference voltage and a G&D pin. Pins 2 to 13 are digital pins respectively. By connecting hardware compatible with Arduino to these pins and with the right code, we can perform physical operations. For example, we can light a simple LED or perform more difficult operations. Of course, there are many fun projects that we can do in turn. The rest is entirely up to your imagination. The only thing left are the RX and TX pins. These pins are used for communication in Arduino. If you want to exchange data between Arduino and another Arduino or another device, you need to use these pins. The system receives data from the RX input and sends data from the TX output, so you can add more circuits and hardware to your projects. That's it for now, friends. I will try to keep the videos as short as possible so as not to bore you. I will also try to give the most comprehensive and new information about Arduino. Thank you for watching. Don't forget to turn on notifications to be notified of the continuation of the videos. Your ideas and opinions are very important to me, so you can write in the comments. Take care and goodbye.